So we're just past Memorial Day weekend, which is kind of the unofficial start to summer. And summer means cookouts and picnics. And the stereotype of an unwanted picnic guest is ants. Now, I'm not talking about your mom's sister here. I don't know if she was invited or not. But I'm referring to the six-legged variety of ant. And while they're not related to you, they are related to bees, wasps, and sawflies. And as far as insects go, ants kind of have superpowers. So let's get down on our hands and knees and we can get a better look at the humble ant. I'm your host, Tim the Nature Nerd O'Hara, and this is the Dispatches from the Forest podcast. Ants belong to the order Hymenoptera, which, like I mentioned, also includes sawflies, bees, and wasps. Interestingly, ants actually evolved from a lineage of stinging wasps. The name ant evolved from a word that means the biter, which for many species is an excellent description. Now, it's estimated that there's over 20,000 species of ant on the planet, but entomologists have only identified about 15,700 species and subspecies. The total number of individual ants on the planet? Well, a recent study conservatively estimated that number at a staggering 20 quadrillion. That's 20,000 trillion. Honestly, it's a number so big it hardly even makes sense. But if you weighed all of the ants, they would weigh more than all of the wild birds and mammals on the planet. That's a lot of ants. Luckily, they don't all show up to your picnic at once. Ants have a cosmopolitan distribution. They can be found on every continent except Antarctica, and there's only a few large islands like Greenland, Iceland, parts of Polynesia, and the Hawaiian Islands that don't have a native ant species. The greatest number of ant species are found in Africa, about 2,500, followed relatively closely by South America at just over 2,100 and Asia at just under 2,100. North America is home to a comparatively paltry 580 species. Now, despite the vast number of species, most ants share some common characteristics, but of course there's always exceptions. So let's start at the head, where most of the sensory organs are found. Ants have strong mandibles, used for carrying food, manipulating objects, constructing nests, and, in some species, defense when needed. They actually have two sets of jaws. The outer pair is used for carrying objects and digging, and the inner pair is used for chewing. Remember that I said that ants kind of have superpowers? The average ant can lift 50 times its own body weight. That's like me bench pressing somewhere in the neighborhood of 8,000 pounds. Do you even lift, bro? Some species of ant have a small pocket inside the mouth where food can be stored so it can be passed to other ants or larvae. Sometimes referred to as the social stomach, the fancy name for this pocket is the infrabuccal chamber. Like a lot of insects, ants have compound eyes. Now, ant eyes are generally good at detecting movement, but in most species they don't offer a high-definition image. 3 small simple eyes on the top of the head detect light levels and polarization. But like I said, there's always exceptions. There are cave-dwelling ants that are completely blind, and ants like the bulldog ant of Australia that have excellent vision and can discriminate the distance and size of objects moving up to 4 feet away. Also on the head are the antennae. Ants have geniculate or elbowed antennae. A joint in the middle lets the antenna bend. Their antennae are used to detect chemicals, air currents, and vibrations. They're also used to communicate. And let me tell you, ant communication is fascinating. So I'm going to go off on a bit of a tangent here. The primary way that ants communicate is through pheromones, which they detect with their antennae. Using pheromones, they can communicate everything from colony activity to the best route home to the location of food. A crushed ant will emit an alarm pheromone that sends nearby ants into an attack frenzy and attracts even more ants from farther away. Several ant species even use what's called propaganda pheromones to confuse enemy ants and make them fight among themselves. Since most ants live on the ground, they use the soil surface to leave pheromone trails that can be followed by other ants. In species that forage in groups, a forager that finds food marks a trail on the way back to the colony. This trail is followed by other ants, and these ants reinforce the trail when they head back to the colony with food. When the food source is exhausted, no new trails are marked by returning ants, and the scent slowly dissipates. This behavior helps ants deal with changes in their environment. For instance, when an established path to food is blocked, the foragers leave the path to find a new route. If successful, it leaves a new trail marking the shortest route on its return. Successful trails are followed by more ants, reinforcing the better routes and gradually identifying the best path. This is why you frequently see long lines of ants, often traveling in both directions. Now, it's not a perfect system, and occasionally it goes awry, resulting in a phenomenon known as an ant mill or death spiral. This generally happens when a group of ants gets separated from the main foraging party and loses the pheromone trail, and instead they start to follow each other, forming a continuously rotating circle. They'll continue to spiral like this until they die of exhaustion. Now, in addition to pheromones, ants can send messages with their antennae by tapping or grabbing another ant with them. Stroking and tapping of antennae seems to communicate how they feel about each other and allows them to smell each other. The number and speed of antenna taps can communicate the age of the ant and how well nourished it is at that moment, which is important for determining if it's healthy enough to take care of eggs or young. If an ant smells like it's sick, it may not be allowed to continue back to the colony because of possible contamination. Some ant species also use sound or vibration to communicate. As small as they are, they can detect the vibrations from other ants walking on leaves or twigs. Rubbing their feet on leaves and twigs produces a sound that can be detected by other ants up to 100 feet away. Stridulation, making sounds by rubbing body parts together, is used by some ants too. And much like their honeybee cousins, ants use body language to convey a great deal of information to one another. If a worker ant finds food, its body language communicates to other workers how far away the food is. The way the ant moves its head and body, and how fast or slow it crawls around provides information on how close they are to the food source and how long it will take to get there. Okay, back to the ant's body. After the head, the terms for ant body parts can get a little bit complicated. Most insects have just a head, a thorax, and an abdomen, but because of the way different segments of ants are fused together, sometimes different terms are applied. But for the sake of simplicity, we're just going to stick with head, thorax, and abdomen. So behind the head is the thorax, which constricts into a petiole, the technical term for the slim waist of certain ants, bees, and wasps. The thorax is where the legs, and if they have them, the wings attach. Ant legs have hooked claws on the ends that let them climb. Most people think that only queen ants have wings, but that's not exactly true. Reproductive ants, both queens and males, often have wings, at least in most species. Queens will shed their wings after what's called the nuptial flight. This is when virgin queens mate with males and then start a new colony, leaving visible stubs, which is a distinguishing feature of queens. I'll talk a little more about the ant life cycle in just a minute. Also found on the thorax of many species, and unique to ants, is something called the metapleural gland. This gland secretes an antibiotic liquid that's groomed onto the ant's exoskeleton. The liquid helps prevent the growth of bacteria and fungal spores, both on the ants and inside the nest. Most male ants lack this gland, but they benefit from the shared secretions of the female worker ants. Likewise, slave-making ants, a group of ant species that I'll tell you about a little later, benefit from the secretions of the species they enslave. Other ant species that lack this gland have different strategies for reducing parasites, like increased grooming or even venom production. Okay, finally we come to the abdomen. This is where most of the internal organs are located, including the reproductive, respiratory, and excretory systems. The egg-laying structure of worker ants in many species is modified into a stinger that's used for both subduing prey and defending the nest. They are, after all, descended from wasps. So now a brief note on insect biology. Insects don't have lungs. Oxygen and other gases like carbon dioxide pass through their exoskeleton through tiny valves called spiracles. Insects also lack closed blood vessels. Instead, they have a long, thin, perforated tube along the top of the body called the dorsal aorta. This functions like a heart and pumps hemolymph, the insect version of blood, towards the head, driving the circulation of the internal fluids. The nervous system consists of a ventral nerve cord that runs the length of the body, with several ganglia and branches along the way leading out to the extremities of the appendages. Now, an ant colony is very similar to a beehive. The queen and the workers are all females. Males are called drones and have a single purpose in life, to mate with the queens. Workers can live 1 to 3 years, but males only survive a few weeks. Once their job is done, so are they. Depending on the species, queens can live up to 30 years, about 100 times longer than similarly sized solitary insects. A wide range of reproductive strategies have been noted in ant species. Females of many species are capable of reproducing asexually through parthenogenesis, producing female offspring without the need for mating. Most ant species have a system in which only the existing queen and new queens are able to mate. But contrary to popular belief, some ant nests have multiple queens and others may have no queen at all. In queenless colonies, some workers are able to mate. In species like army ants, drones mate with existing queens by entering a foreign colony, but that's a risky proposition. When the intruding drone is initially attacked by the workers, it releases a mating pheromone. If it's recognized as a mate, it'll be carried to the queen to mate. If not, well, he died trying. Most ants produce a new generation each year. During the breeding period, winged males and females leave their natal colonies in, like I mentioned, what's called a nuptial flight, although this makes it sound like they fly off together holding hands. That's not how it works. The nuptial flight usually takes place in the late spring or early summer when the weather is hot and humid. Heat makes flying easier, and freshly fallen rain makes the ground softer for newly mated queens to start digging a nest. Males typically leave before the females and use visual cues to find a common mating ground. For example, a particular pine tree where other males in the area converge. Males secrete a mating pheromone that the females then follow. Males will mount females in the air, but the actual mating process usually takes place on the ground. Depending on the species, females may mate with just one male, or they might mate with as many as 10 or more different males. They can store the sperm for later use. In species with wingless queens, workers transport newly emerged queens to other nests of the same species where wingless males from unrelated colonies can then mate with them. After mating, females look for a suitable place to start a new colony. Once they find it, they break off their wings and start laying and caring for eggs. The females can selectively fertilize future eggs with the stored sperm to produce workers or lay unfertilized eggs to produce drones. The first workers to hatch are smaller and weaker than later workers, but they begin to serve the colony immediately. They enlarge the nest, forage for food, and care for the eggs. Species that have multiple queens may have a queen leave the nest along with a group of workers to found a colony at a new site, a process very similar to swarming in honeybees. Ant larvae undergo several molts before pupating into adults. Ant larvae are largely immobile and are fed and cared for by workers. Food is given to the larvae by a process called trophallaxis, which is a fancy word that means workers puke up liquid food to share. Yummy! In later stages, larvae may be given solid food like pieces of prey or seeds. Larvae and pupa need to be kept at a fairly constant temperature to ensure proper development, so they're often moved between various brood chambers within the colony. A newly pupated worker ant spends her first few days caring for the queen and the young. She then graduates to digging and other nest work, and later on to defending the nest and foraging. Interestingly, a possible explanation for this sequence is that the high casualty rate involved in foraging makes it an acceptable risk only for ants who are older and likely to die of natural causes soon anyhow. Okay, now let's dive into some specific ant species. I'm going to start with the bullet ant. You may have heard of this ant, which is named for its painful sting. They're fairly large, growing to be between 3/4 and 1.25 inches long, and they're reddish black. Bullet ants are found throughout Central and South America. Colonies of bullet ants consist of several hundred individuals and are usually situated at the base of trees. Workers forage in the trees in the area directly above the nest for small arthropods and nectar. Very little foraging occurs on the forest floor. Nectar is carried with the mandibles, and it's the most common food taken back to the nest by the foraging bullet ants. Now, bullet ants aren't aggressive, but they are vicious when they're defending their nest. In this case, they produce a stridulating sound and they sting with ferocity. And that sting is considered to be one of the most painful stings in the insect world, rating a 4.0 plus on the Schmidt pain scale. On a side note, the Schmidt pain scale was created by entomologist Justin O. Schmidt. Originally published in 1983, Schmidt's paper included a table with a column that rated sting pain, from 0 for stings that are completely ineffective against humans, progressing through 2 for familiar pain like a common bee or wasp sting, and maxing out at 4 for the most painful stings. Schmidt claimed to have been stung by the majority of stinging members of the order Hymenoptera, and at the time, only the bullet ant rated a 4, although later revisions added a couple of others. Schmidt described the bullet ant sting as, quote, pure, intense, brilliant pain, like walking over flaming charcoal with a 3-inch nail embedded in your heel. This pain can last up to 24 hours. Now, we don't have bullet ants in North America, but we do have fire ants. There's actually over 200 species of fire ant, but in North America, the red imported fire ant is an invasive species. Native to South America, they were first introduced, accidentally, into Alabama in the 1970s and have since spread throughout the southern United States. If you've lived in the South, you're probably familiar with these pesky little so-and-sos. Red and small, just a 1/4 inch long, a fire ant colony can consist of up to 250,000 individuals. They build large mounds which they defend vigorously and in mass, inflicting multiple painful stings, as anyone who's accidentally stood on one can attest to. And to answer the question that you're thinking, yes, I have. In spite of the risk and getting stung when accidentally disturbing a nest, when we lived in Louisiana, my kids were fascinated by fire ant mounds and would poke them with a stick just to see the ants come swarming out. Now, despite their small size, fire ants excavate large quantities of soil when building their colonies, and they can actually cause structural problems for driveways, patios, and sidewalks. Additional damage by mounds can be inflicted on trees, yard plants, and pipes, and if that isn't bad enough, they're attracted to electricity. Electrically stimulated workers release venom, alarm pheromones, and recruitment pheromones, which only attracts more workers to the site. As a result, red imported fire ants can cause electrical shorts and destroy electrical equipment. The U.S. Food and Drug Administration estimates that more than $5 billion is spent annually on medical treatment, damage, and control of these ants in infested areas. Now, the reason that these little buggers have been so successful is that they're very adaptable and resilient. Most notably, they're able to contend with both drought and flooding. If the ants sense an increased water level in their nest, they link together to form what's called a ball or a raft that floats, with the workers on the outside and the queen on the inside. This way the brood is floated up to the highest surface. I've actually seen this, and it's pretty amazing. The workers form the foundation of the raft. In some cases, workers will deliberately remove all males from the raft and let them drown. A raft of fire ants can survive as long as 12 days. Ants that are trapped underwater escape by lifting themselves to the surface using bubbles collected from submerged substrate. Because they're more vulnerable to predators during this time, fire ants are significantly more aggressive when rafting. Workers tend to deliver higher doses of venom in order to reduce the threat of animals attacking. Because of this, and because more ants are usually present, fire ant rafts are extra dangerous to anything that encounters them. In some places, red imported fire ants are being displaced by another invasive ant, the tawny crazy ant, sometimes called the hairy crazy ant, which may or may not also describe your mom's sister. But this is not necessarily good news because they're just as numerous and just as defensive, although on the upside, their bite is less painful. Unlike fire ants, colonies live under rocks or other debris, and they don't build large mounds. In parts of its native range in South America, tawny crazy ants have displaced all other ant species. Small poultry like chickens have died of asphyxiation after being attacked, and larger animals like cattle have been attacked around the eyes, nostrils, and hooves. Grasslands have dried out because of an increase in plant-sucking aphids, which the ants cultivate to feed on the sugary honeydew that the aphids excrete. When attacked, tawny crazy ants don't sting like fire ants do, they bite, and they excrete formic acid, which they use as a venom. What's really interesting, though, is that they can use this formic acid as an antidote to the much more toxic venom of the fire ant. When exposed to fire ant venom, a crazy ant retreats, covers itself with formic acid, and then returns to the fight. This is the first known example of an insect detoxifying another insect's venom. Research has shown that this behavior helps tawny crazy ants survive fire ant venom 98% of the time. When prevented from producing formic acid, crazy ants had only a 48% chance of surviving fights with fire ants. The world of ants is brutal. There's another group of ant species I mentioned earlier known as slave maker ants. These ants are brood parasites. They raid and capture the broods of other ant species to increase their own worker force. Slave-making ants are specialized to parasitize a single species or group of related species, and they're often closely related to the species that they raid. The slave maker workers are specialized for conducting raids in a two-step process. First, scouts search for potential host nests individually. When they find one, they return to their own nest and recruit nestmates to initiate the raid, during which slave maker ants seize a brood and bring it back home. A colony may capture 14,000 pupae in a single season. The pupae become imprinted on the chemical odor of the slave-making ants, so the captive ants forage and routinely return to the slave-making ant nest. But raiding isn't the only method used by slave-maker ants. In one African species, the queen allows herself to be dragged into the nest of tapenoma ants. She then bites the head off the tapenoma queen and lays her own eggs, which are then cared for by the tapenoma workers. Who needs Game of Thrones when you have ants? Okay, the final ant I want to talk about is carpenter ants, but not so much because of the ant, but rather for the zombie ant fungus, also called cordyceps, that commonly infects them. If you've played the game or seen the TV show The Last of Us, you've heard of cordyceps. The idea is based on this zombie ant fungus. The zombie ant fungus begins its life cycle as a sticky spore on the forest floor. If the spore attaches to the body of a passing carpenter ant, it germinates thread-like strands which eventually breach the ant's exoskeleton. Once successfully inside the ant body, the fungus grows and manipulates the ant's behavior. When the fungal mass inside an infected ant reaches a critical size, usually 2 to 3 weeks after infection, the ant is induced to leave its nest at a different time than it would normally during foraging, and it fails to follow established ant trails. Infected ants are generally unresponsive to external stimuli, including other ants. Sporadic convulsions will make the ant fall to the forest floor if it's not already there, where its movements become increasingly aimless. Eventually, the infected ant is compelled to climb a low-growing plant, orient its body in a specific way on the vegetation, and permanently lock its mandibles to the plant. This death grip is closely synchronized with the extent of the infection and is the final act of the ant. Death follows shortly thereafter. After the ant dies, the fungus finishes digesting the cadaver from the inside out, and as its final act, erects a triumphant stalk from the base of its host's head. The stalk releases spores, and the cycle continues. Wow! Carpenter ants in areas with zombie ant fungus have evolved several adaptations to limit their exposure. Ants in infested areas tend to be more arboreal, spending more time in the trees than those where the threat of fungus is lower, suggesting that they avoid the forest floor to avoid the spores of the fungus. They also practice social grooming to help remove spores from each other's bodies before infection can occur. Carpenter ants have been observed carrying infected members of the colony away from the nest, away from their usual trails on the forest floor to reduce the risk of spreading spores in high traffic areas, and they're known to actively avoid the graveyards of the infected dead. Fortunately, cordyceps can't actually infect humans. Yet. And with that, I'll bring this episode to a close. Thank you as always for listening. Please click those like and follow buttons. It's free and can potentially help me out a lot. If you want to support future episodes of the podcast, here's some ways you can do that. Go get yourself some sweet Dispatches from the Forest merchandise. Check out the Dispatches from the Forest merch store at cafepress.com/Dispatches from the Forest. There's t-shirts, water bottles, hoodies, and much, much more. Check out our Patreon page and consider becoming a patron. You can do that at patreon.com/Dispatches from the Forest. If you want to make a one-time donation, you can do that through PayPal. dispatchesfromtheforest@gmail.com is both my PayPal address and how you can contact me if you have any questions, comments, or suggestions for future episodes. For additional content, follow Dispatches from the Forest on Instagram, Facebook, and TikTok. And coming soon to YouTube, I swear I've got some videos. I just need to edit them and get them posted. Stay tuned, because there will be stuff on YouTube soon. I'm your host, Tim the Nature Nerd O'Hara, reminding you to go outside and get dirty. The Dispatches from the Forest podcast is a production of Dispatches from the Forest and may not be used or rebroadcast whole or in part without express written permission. The ants go marching one by one, hurrah, hurrah. The ants go marching one by one, hurrah, hurrah. The ants go marching one by one, the little one stops to suck his thumb, and they all go marching down to the ground to get out of the rain. Boom, boom, boom. The ants go marching two by two, hurrah.